So if we think about currents and circuits, obviously if we think about let's just suppose we've got a lamp, a cell with a lamp, current's going around, it's flowing around. If we took a close-up look at the actual wire, what's going on in the wire, well, anything's made of atoms, and as you probably know, atoms have got positive nuclei in the centre, with this cloud of C and negative electrons around. And the ratio of electrons to protons must be the same. So this is 1, 2, 3, I'll put 3 on each of these, that would be lithium, which is a bad example, you know, when you make a circuit out of lithium, it's a bit dangerous. But if we were to do that, this atom can only hold 3 electrons. This one can only hold 3, this one can only hold 3. But they don't care which 3 they hold. So you basically imagine a jugglers juggling 3 balls each, 3 jugglers all juggling 3 balls. If we chuck an extra electron on this one, what will happen is we'll be like, I can't hold 4 balls, I'm going to chuck one to my mate here. And he'll instantly chuck one to his mate here, and this one will instantly chuck one out. And so, in a second this one goes on, all the electrons move across one, and one pops out this way. And this is what goes on in circuits, okay? It's a little bit, you can think of it, a little bit like marbles in a hose pipe. This is what I like to think of. If you imagine a hose pipe full of marbles, you get a marble, poke it in one end of the hose pipe, immediately one pops out the other end. This is why people think that electricity travels at the speed of light or very fast, because you flick on a switch and instantly the light comes on. But it doesn't, it flows very slowly. We're talking about millimetres per second. But of course, it's an instantaneous effect. As soon as I poke one in, one pops out the other end. And so, this is what's going on in circuits. Now, as a result of this, if I've got a battery, I'm going to draw my battery, there we go, and I plug it in to a lamp like this. If one electron's going in this end per second, there's going to be more than one, but if one electron was going in, well, let's say this end per second, then one will be popping out the other end per second. I don't want to worry about the direction of the electrons right now, but if one's going past that point every second, one's going past that point every second. Now, I'm going to leave the directions of those out for this particular moment. So what that means is the current in the battery is the same as the current in the lamp. If I had 2, it's still the same. If one's popping into there, one's popping into there, one's popping into there, one's moving everywhere. So the rate of flow of charge is the same everywhere in a series circuit. But if we think about a parallel circuit now, draw this, and then draw it doing something like this. Well, if I'm poking, let's say I've got one going through there per second and one going through there per second, it must stand to reason that I've got 2 coming down, one's going one way, one's going the other way. They're going separately at 1 electron per second, and then here I've got 1 electron per second, and now I've got 2 go that way. Best not to think of electrons per second, it's better to think of current, okay? 2 amps there, 1 amp there, 1 amp there, and this picks back up there. And so this is just the idea of conservation of charge. Okay?